In this video, we're going to look at some strategies in solving trigonometric integrals. The basic strategy is to apply a trig identity as sine squared x plus cos squared x is equal to 1, and U substitution, u is equal to sine x or u is equal to cos x. Here we have the integral of sine x to the power of m multiplied by cos x to the power of n integrated with respect to x. M and n are integers. If either m or n is odd, reduce odd power by 1, save a factor of sine x or cos x, and apply trig identity sine squared x plus cos squared x is equal to 1. Here we have a question, integrate sine cubed x dx. The first step is to split off a factor of sine x. Let's do that. So what we have is integral sine squared x times sine x dx. So now we're going to use a trig identity. We're going to express sine squared x in terms of cos squared x. And the reason for that is we can do a U substitution afterwards. So we have integral sine squared x is equal to 1 minus cos squared x times sine x dx. Now let's do a U substitution. Let u be equal to cos x. Its derivative is going to take care of sine x dx. It's going to take care of this one. So du is equal to minus sine x dx. We can put the minus out in the front. We have 1 minus u squared. And sine x dx minus sine x dx, that's just du. Now let's integrate term by term. We get minus. Integral of 1 is u. Integral of u squared, reverse the power rule, that's u cubed, divide by 3, plus c. Now let's distribute the minus 1, we get minus u, plus u cubed over 3, plus c. Let's substitute u is equal to cosine x, we get minus cosine x, plus cosine cubed x, divide by 3, plus constant c. So this is the answer for the integral of sine cubed x dx. Alright, let's look at another example. Here we have integral sine squared x times cosine cubed x dx. So we're going to reduce the odd power by 1. Here the odd power is the cosine. We have cosine cubed x, so we'll reduce it as cosine squared x times cosine x. And so now we're going to use a trig identity. And we have sine squared x. And cos squared x can be rewritten in terms of sine. That's 1 minus sine squared x multiplied by cos x dx. So now we're going to do our substitution. So you can see how we're going to let u be equal to sine x. So this part will be u squared. This part will be 1 minus u squared. And derivative of sine x is cos x. So this part will be du. Let's do that formally. So we have u is equal to sine x du is equal to cosine x dx. Transforming the integral, we get integral u squared times 1 minus u squared multiplied by du. Now let's solve this. Let's simplify the integrand. Distribute the u squared. We get u squared minus u to the 4th du. Let's integrate term by term. The integral of u squared is u cubed. Reversing the power rule, divide by 3 minus integral of u to the 4th is going to be u to the 5 over 5 plus constant c. Now let's substitute u is equal to sine x back in to get our answer in terms of x. So we have sine x, that gives us sine cubed x, divide by 3, minus sine to the 5x, divide by 5, plus c. So the integral of sine squared x cosine cubed x dx is what is given in the above statement. That's going to be sine cubed x over 3 minus sine to the 5x divided by 5 plus c. All right, another question. Here we have integral sine cubed x times cosine x to the power of minus 2. So it's a little bit different than what we've done. We've got a negative power. So the first thing we do is split off a factor of sine x, reduce odd power by 1. So we have integral sine squared x times sine x times cos x to the power of minus 2. All right, let's rearrange this integral. So what we have is integral sine squared x times sine x times 1 over cosine x to the power of 2 dx. All right, so now we're going to use a trig identity and write sine squared x as 1 minus cos squared x. So let's write that in. That's 1 minus cos squared x times 1 over cos x all squared. And let me write sine x along with the dx so that we can see the U substitution at work. So we're now going to let u be equal to cosine x, because its derivative is going to take care of sine x dx. So u is equal to cos x. Du, its derivative, is going to be minus sine x dx. So let's now get everything in terms of u. Let's transform the integral. We get 1 minus cosine squared x, that's u squared, times 1 over cos x squared, that's u squared, times sine x dx. Solving for sine x dx, that gives us minus du if you divide both sides by negative 1. So let me put the minus out in front. So now what we get is minus, distributing the 1 over u squared, 1 over u squared, minus u squared over u squared, that's just 1, integrated with respect to u. All right, so we'll rewrite it as u to the minus 2. That makes it easier to apply the reverse of the power rule. So let's now integrate this, and we get minus. Integral of u to the minus 2 is u to the minus 2 plus 1 divide by minus 2 plus 1. And integral of 1 is just going to be u plus c. So let's simplify this. We get minus u to the 1 minus 2 is negative 1 over 1 minus 2 is minus 1 minus u plus c. Now distribute the minus 1, we get 1 over u, because u to the minus 1 is the same as 1 over u, and minus times minus u gives us plus u plus c. All right, so now let's put u back in, so we get our answer in terms of x. So what we have is 1 over cos x plus cosine x plus c. So the answer to the integral sine cubed x times cos x to the power of minus 2 dx, is going to be 1 over cos x plus cos x plus c. All right, thanks.